Okay, so today we want to talk about subtracting fractions. Subtracting fractions is very similar to adding fractions. The only thing that we're going to have to add to this particular PowerPoint is when you're subtracting fractions, sometimes you have to borrow fractions, okay? And so we'll talk about borrowing. Let's review how to take care of fractions that have the same denominator first. So if I have fractions, just like with adding, that I'm subtracting, and the denominators are the same, the first thing I want to do is write down the denominator that they have in common, and then I want to subtract the numerators. After I subtract the numerators, I want to make sure that the fraction is reduced as low as it can go. So what would I get for this fraction? 2 over 9. Okay, we're going to write the 9 down, then we're going to take 8 minus 6, we get 2. And 2 over 9 can't be reduced, so I just move on to the next problem. What about this fraction? What would I get for my answer?
7 over 6.
No, not 7 over 6.
No, 7 over 7.
7 over 7. And what does 7 over 7 equal? 1. So don't forget to simplify your fractions. Okay, what about this example? What should I get?
2 over 4.
But if I get 2 over 4, is that reduced as low as it can go? No, then I can reduce it down to what?
1/2.
A half. So 2 over 4 can be reduced by 2, and I would get 1/2. Now, what about this fraction here, this problem, where I have 6's? What would I have on top? 8 over 6, but 8 over 6 can be reduced to what mixed number?
1 and 2 6.
And 1 and 2 6 can be reduced down to what?
1/3.
So my answer should be 1 and what?
1/3.
1/3. Okay? So I got 8 over 6 initially, but I could reduce, and you have a choice. You could either make this a mixed number first like I did, and then reduce the fraction, or you could have reduced this down to 4 over 3 and then made it a mixed number. So you have a choice on that end, but you've got to do both processes. You've got to reduce it and you've got to simplify it. Okay? So my final answer here is going to be 1 and 1/3 after I reduce the 2 and the 6 by 2. So don't forget to reduce and simplify if necessary. Now when you have a lot of different steps, you always want to line up your problems like buttons on a shirt vertically. Sometimes this is just a nice method to do your problem so it doesn't get too messy and you can work on the side. If I were to actually subtract this, I would get 8 minus 2, which gives me 6 over 9, and that reduces to what? What does 6 over 9 become? 2/3. And then what about my whole number here? 11 minus 7 is what? 4. So my final answer should be 4 and 2/3, right? So I get 6 over 9, I reduced this by 3 to get 2/3, and then I took 11 minus 7 and I got 4. So you have to remember to simplify and reduce. Now, you have work to do if the fraction's denominator is not the same. You're going to do the same work that you did when you added fractions last week, okay? So find that LCD, raise the fractions, and then start subtracting. So if the denominators are different, find the LCD, which is the same thing as your LCM. Raise the fractions using multiplication to that LCD, and then you can subtract the numerators and simplify or reduce. Okay? So let's do a couple of these. Remember, find the LCD, raise the fraction, then write down the common denominator and subtract the numerators. If you need to reduce or simplify, then don't forget to reduce and simplify. Now, for the LCD, let me see if I even gave you some LCD practice here, because you had some on your addition packet. For the LCD, what would the LCD be for 7 and 2? What's the LCD? 14. So you can make a multiple list and see what you have in common, that's the smallest, or you can use the shortcut that I taught you. Go to the largest one, in this case it's 7, and do multiples of the 7, and then just compare it to the 2. I know that 7 times 1 is 7, but 2 will not go into 7 evenly. 7 times 2 is 14, well 2 and 7 go into 14, so that's my LCD, that's the shortcut. What about 9 and 6, what's the LCD?
36.
Nope, there's one smaller.
What's
18.
18. 36 is a common denominator I could use, but I'd have to reduce more. So I want the least common denominator, and that would be 18. So you can do a multiple list, or excuse me, you can do a multiple list, or you can just do a comparison with the shortcut to get 18 as the least common denominator. Let's do a couple more. What about for 6 and 15? What would be the LCD? 6 and 15. 30. Okay. And what about 3 and 13? What's the LCD? 3 and 13.
33.
A little bit higher. What's 3 times 13?
Oh, let's go.
39, yeah. And that's because both 3 and 13 are prime numbers, so I have to multiply them to get the least common denominator. So 39 would be my LCD. So if I have 2/3 and I'm subtracting 1/2, what's my LCD? For 3 and 2, what's the LCD? 6. So I need to raise both fractions to 6. So here I'm going to multiply by 2 to get 6 on the bottom. And here I'm going to multiply by 3 to get 6 on the bottom. So when I do that, my new equivalent fractions become, here we're going to multiply by 2. We get 4 over 6. Here we're going to multiply by 3. We get 3 over 6. So now that I have the same denominator, I can subtract. So 6 is my denominator, and I'm going to just take 4 minus 3. So you have to remember that once you get your LCD, you need to raise the fractions to the LCD by multiplying both the numerator and denominator by the same factor. And then once you get the equivalent fraction, then you can subtract. Okay, here I've got 3/4 and 1/5. The least common denominator is 20. So I'm going to raise both to 20. On the first fraction, I'm going to be multiplying by 5. So I'm going to get 15 over 20 for my equivalent fraction. And then on the second fraction, I'm going to multiply by 4. And I'm going to get 4 over 20. So what's my answer here? Looking at the equivalent fractions, what's my answer? 11 over 20, which I can't reduce. So I'm done with this problem. For 4 and 3, we know the LCD is 12, so we're going to multiply the top and the bottom to get 12. On top, we're going to multiply by 3. On the bottom, we're going to multiply by 4 to get 12. So my equivalent fractions will be 9 over 12 minus 8 over 12. Now I can subtract. Now I'm going to get 1/12 for the fraction, and the whole number I'm going to get 5. Because I'm subtracting 7 minus 2, I get 5. Here I'm subtracting 9 minus 8, and I get 1. 1 over 12 is as low as I can go, so that's my final answer. So you always need to check and make sure that you reduced and simplified as low as you could. Here I'm going to raise to 18 because I have 6 and 9. On top I'm going to multiply by 3. On the bottom I'm going to multiply by 2. My equivalent fractions are going to be 15 over 18 and 6 over 18. That will leave me with 9 over 18. Can I reduce 9 over 18? To a half, right. And then 9 minus 3 is 6. So I should get 6 and a half for my final answer. So remember, you need to reduce by the same factor if necessary. Now let's talk about borrowing. Borrowing is only going to be applied to subtraction. And let's talk about when you need to borrow. Because some people have never borrowed with fractions. Now, I have the fraction 4 and 3/4 and 2 and 9/10. First of all, both of these fractions do not have the same denominator, so I have to find the LCD. What's the LCD for 4 and 10? What number? 20. So I'm going to, well, we could have just used a shortcut for that. So 20 is the LCD. So I'm going to raise both fractions to 20 and get my equivalent fractions. That's the first thing I'm going to do. On the bottom, I'll be multiplying by 2. On the top, I'll be multiplying by 5. So my two equivalent fractions are going to be 15 over 20 and 18 over 20. So let me go to the next page here. What's the first problem I have when I try to do this problem now that I've raised the fractions? Can I take 18 from 15? No. So when I cannot subtract the second fraction's numerator from the first fraction's numerator, I have to borrow. This is a borrow situation. I cannot do the subtraction here. The second fraction's numerator is too big. So the way that I do that is I go borrow just like I would borrow a whole number. Where do I go borrow? Where the 4 is. So I borrow 1 from the 4. It becomes a 3. Now the 1 that I took away from the 4 comes next to the fraction that's too small, and I'm going to break it into pieces like a pizza. And the pieces are going to be based on the common denominator. What's my common denominator here? 20. So I have to say 20 over 20. Now I need to add those, okay? I'm sorry, you guys. I need to add those. That's my kid. When I add them, what do I get? Well, I have to take the fraction that was too small and add it to the 1 that I just broke up. How much is this going to be?
So wait, you add the 15 to
Yeah, I got to take the 15 and make it bigger because I borrowed to make it bigger.
So 35?
It'll be 35 over 20. Now, I take 35 and subtract 18, and I'm going to get 17 over 20. So what you have to do when you borrow is you go to that fraction that's too small. Go to its whole number in the mixed number, borrow 1 from it, and then break it up into the pieces based on the common denominator over itself. Because the common denominator over itself is still 1. I'm just breaking it up into pieces so I can add it to the fraction and make it bigger. So that gives me 17 over 20. Then I subtract 3 and 2, which are my whole numbers. And my final answer is 1 and 17 over 20. Let's do another one. Now, what's wrong with this problem? Can I take 7/12 from nothing? So I got to come over to this 3 and borrow. It becomes what now? 2. And then what is going to be the 1 that I'm going to break up? What's the denominator?
12.
12. So that 1 that I took away from 3 is 12 over 12 based on the denominator. There's only one denominator in this problem. So the common denominator would be 12 over 12. Now I can subtract. I get 5 over 12, and 2 minus nothing is 2. So that's how you would subtract a problem like that. And you guys will have a couple like that, okay? So, what am I going to do here?
Borrow again.
Borrow. What happens to the 8?
It's a 7.
Becomes a 7. Okay, Chris, and then what do I do? That's right, Amber. 25 over 25. This 1 gets broken up into the common denominator over itself, and the only denominator I have is 25.
So it's 125.
That's right. 4 and 1 over 25. Okay, so does this seem pretty easy?
Yeah.
All right, now let's do one where we have to raise the fraction, okay? Because that's got extra steps. I don't want you guys to forget how to raise the fraction. Since I have 6 and 15, I have to raise the fraction to 30, right? So first I do that. And I know it's 30 because I just used a shortcut and I got 30. Or you can use the list I used here. So I'm going to raise both of these to 30 before I see if I have to borrow. I'm going to multiply the bottom by 2 and get 26 over 30. And I'm going to multiply the top fraction by 5 and get 25 over 30. So, can I take 26 from 25? No. 26 is too big to subtract from 25. So you're right, Chris. I borrow from the 9. It becomes an 8. Then what do I have to do? What happens to that 1 I just borrowed? What's the common denominator?
30.
So I got to add 30 over 30. Now I got enough. I've got 55 over 30. I can take 26 from 55. So you have to add. There's some addition in this subtraction, okay? You got to add that 1 that you broke up into the common denominator over itself to the fraction that's too small. And that's going to give you 29 over 30, which I can't reduce. And 8 minus 8 is 0, so all I have left is the fraction. So my answer to this problem is 29 over 30, and I can move on to the next problem. Any questions about this one where I had to go get the 30 over 30 and add it and then subtract? That's how you borrow. So these are the rules. First, find your LCD if the denominators are different. Then raise your fractions to the common denominator. See if you need to borrow when you're subtracting. Then write down your numerator and denominator. Make sure they're simplified and reduced as low as they can be. All right? So go to your packet, and let's look at your packet for a second. Let me tell you what's in your packet. The first page just talks about doing your pre-test and post-test once you finish the packet, just like normal. And then you guys only have to do subtraction here. There's no extra steps because there's enough steps in the subtraction. So on practice set A, you have different denominators. You're going to raise your fractions, subtract the numerators, borrow if you need to. Page 4 just talks about how to borrow and how to subtract mixed numbers. Page 5 has some more examples on how to borrow. And of course, you guys can ask me questions too. I'm right here. I don't want to be lonely, so come and talk to me too. Then on page 6, you have a variety of problems. Some of them don't have the same denominator. So you're going to have to get a least common denominator and subtract them. And a couple of them do have the same denominator. And you'll just handle the like denominators like you would normally. You don't have to raise them. I see one right here with the 8s. Then on page 7, you have a mixed review of the different types of fractions. Some of them have borrowing in them for sure, with a couple of word problems. And you have some extended math labs on page 8 to do on the internet. But you can do that at home for homework. You might want to try to see if you can get the packet done today. So if you have questions, you can ask me. And for homework tonight, you're going to have the pre-test, the post-test, and that extended practice on the last page. So let me know if you have any other questions as you're working through these, especially with the borrowing. We can put them on the board. Any questions at all? You guys know what to do? Okay.
Almost done.
Okay, great. If you're almost done, that's wonderful. Do your tests and stuff. Alrighty.
This thing is falling.